Hello everyone, welcome back to Jada Solved. It's me, your resident engineer, Jada, and I'm going to talk to you about 5 engineering mistakes that are so catastrophic that they either lost lives, lost millions, or nearly did that. Just to make you feel better about your next mistake, because everyone makes mistakes, but I'm sure your mistakes aren't as bad as these ones. If you like videos like this where I talk about history and engineering and just general facts, make sure you put down in the comments what you like about it, and I'd love to hear it. Case 1, the Tacoma Narrows Bridge. November the 7th, 1940 in Washington State. The Tacoma Narrows Bridge was only open for about 4 months, nicknamed the Galloping Gertie for its visible vertical oscillations. The bridge collapsed in winds of just 42 miles per hour. The mistake wasn't just ignorance, it was oversimplification. Engineers designed it for static wind load, but completely ignored aerodynamics as a secondary concern. Instead of using open trusses to let the wind pass, they opted for solid plate girders to reduce costs and improve aesthetics. What they didn't account for was the aeroelastic flutter, a self-reinforcing feedback loop where wind's vortices matched the bridge's natural frequency, turning that gentle swaying into catastrophic whipping. The bridge fell into the water. Thankfully, no lives were lost, but the innocence of engineering was forever changed. Tacoma was a huge lesson for many engineers. It forced the birth of wind tunnel testing for stable structures and taught us a brutal lesson about form over function. However, sometimes these lessons aren't carried forward into the future. Case 2, the Hyatt Regency Walkway. July the 7th, 1981, Kansas City. The Hyatt Regency Hotel Atrium was hosting a tea party. Suddenly, the 2 suspended walkways collapsed under its weight, falling 140 feet from the air. The results were catastrophic. 114 people died, 216 were injured. However, what was the root cause? The original design used continuous steel rods running through the ceiling throughout both walkways, but fabricating that was difficult. So the team switched to 2 separate rod assemblies, one holding the upper walkway, another connecting the upper to the lower. That change doubled the load on the critical beam connectors. Those connections were never recalculated, never formally reviewed, and were never stamped by the engineer on record. Hyatt became the catalyst for modern change control protocols. It cemented the legal and the ethical weight of PE stamps, and it proved that in engineering, a simple pencil stroke can mean a matter of life or death, and reminded us that whenever we alter a plan, we can't just continue. We need to review and start verification all the way from the beginning. Case 3, the Hubble Space Telescope. April 1990, the Hubble Space Telescope deployed flawlessly, but when the first images came back, they were fuzzy, not slightly off, fundamentally blurred. The $1.5 billion mission was nearly written off. The flaw wasn't in space, it was in Indiana. Technicians used a device called a null corrector to verify the exact curvature, a spacer within the device that misaligned by just 1.3 millimeters. The mirror was ground to the perfect shape, just the wrong specification. Worse, the 2 independent tests actually flagged the error, but because they were simpler, less precise methods, the team assured that the null corrector was right. Overconfidence blinded them from their own data. The Hubble was eventually saved by a 1993 shuttle mission that installed the correct optics, but the real fix was procedural. NASA overhauled verification culture, mandatory independent reviews, cross-check test methods, and a new humility towards precision. So then next time, they can't make a $1.3 billion mistake again. Case number 4, Mars Climate Orbiter, 1999. September the 23rd, 1999, NASA's Mars Climate Orbiter reached the red planet. But instead of entering a stable orbit, it dove straight into the atmosphere and vaporized. $327 million lost in an instant. The causes weren't anything physical. There wasn't a blown valve or a misplaced component. It was unit conversion. Lockheed Martin provided thrust performance data in pound-force seconds. NASA's navigation assumed that they were in Newton seconds. That tiny mismatch compounded over a 116 million mile journey. By arrival, spacecraft was off course by nearly 100 kilometers. It essentially entered too low, and the atmosphere did the rest. And a simple unit conversion, that's a bit of a rookie mistake when you think about it. If someone quickly checked the units of measure from Lockheed Martin, they might have been able to avoid the catastrophe. Now NASA and other engineering practices use this case to remind ourselves that we're not perfect. Even the smallest mistakes, such as unit conversion, can take us by surprise. And by making sure that we all have standardized units, mandatory sign-offs from multiple parties, and just a simple sanity check to make sure that we're all on the same page goes a long way. Case number 5, the Citigroup Center, 1978. The summer of 1978, a Princeton engineering student, Diane Hartley, was studying the New York skyscraper for a class project. she noticed something troubling. The building's load-bearing braces were bolted, not welded, and the wind calculation only accounted for perpendicular winds. When she ran the numbers for 45-degree diagonal rings, the bolts would fall, and the building would collapse. Hartley contacted the original engineer, William, I'm going to butcher this. Le Mesure. He rechecked his work. She was right. A miscalculation during the design, combined with the last-minute switch from welded to bolted joints, made the skyscraper vulnerable to hurricane-force diagonal winds. William thankfully did not hide this. He alerted the owners, designed an emergency retrofit, and oversaw and convert nighttime welding operation. The work took a while to finish, but it was all worth it because weeks later, Hurricane Ella approached. The building did not fall and still stands till this day. The Citigroup Center became a landmark case for engineering ethics. William could have simply ignored the engineering student, could have dismissed her concerns as a student who doesn't know better. He could have left it as is because essentially, he did finish the job, but he didn't. And in doing so, he did risk his professional reputation. But situations like this remind us that even if your reputation's on the line, ethics don't stop when the job is done. It continues whether you're in the project like William was or away observing like Hartley was. Because in the end, engineers have a professional duty for the well-being and safety of the people we create products for. And it shows that even the best engineers make mistakes. But as long as they're proactive about solving them, it makes a world of difference, even if the world doesn't notice it. 5 mistakes, 5 different scenarios, but the patterns are pretty identical. Missed verification, sudden change in plans, no reviews between workers, over-reliance on simple tests, and a quiet but dangerous assumption of just thinking everything is fine. Modern engineering is not perfect. We still have a long way to go, but because of these past mistakes and much, much more, we've learned to catch the mistakes before they even present themselves. We have 3D models that can simulate failure modes and effects analysis, so we can tell what the point of breakage is without risking anyone's life. We have independent peer reviews, digital twins of projects, and a complete culture shift that treats near misses with the same seriousness as disasters. Next time we see something that's been engineered into existence, think about all the trouble and the stress and the constant reviewing that the engineers must have gone through to make sure that what you're using is safe, sound, and functional. If you want more deep dives into stuff like this, make sure you like and subscribe and comment down what you want to hear from me. And tell me in the comments, what engineering mistake have you learned from your own personal history? Thanks for watching, and I shall see you in the next video. Bye bye.